Welcome to Study Loop.
Since we are given an adiabatic process, in this process the pressure decreases. So the pressure P2 will be lesser than the pressure P1. And this change in pressure is obviously negative. Now, in the same time, there is a change in internal energy. And always the change in internal energy is proportional to the change in temperature. For example, under constant volume, we can say that the change in internal energy is equal to N specific heat capacity under constant volume and the change in temperature. Now, since we're given a specific process here, we need to use relations that are corresponding to this specific process. So, combining two equations that are very known, first is the ideal gas equation, and RT, where we directly see that the temperature and pressure are in proportion. And the second equation is the adiabatic process equation. It is from the textbook. So this is going to be volume. It's going to be gamma minus 1 equals to T2 V2 gamma minus 1. Now, what we will do here is that we will relate these two equations. So by relating these two equations and substituting for the volumes, so here we have volume as a function of the temperature, and we can also place P on the other side, the pressure. When we substitute that into this equation, we obtain the next equation. And the next equation is the T1 on gamma, pressure on 1 minus gamma, is also pressure 1, equals to temperature 2 on gamma, pressure 1 minus gamma 2. Therefore, if we align pressures together on the right-hand side and use the temperature 1 will stay together with the pressures, we can obtain the next relation, which is that temperature 2 gamma will equal to temperature 1 on gamma, and here we have pressure 1 over pressure 2 1 minus gamma. Inverting, so we need to do an inversion of the exponent so that the ratio changes. The ratio will be inverted as well. T2 gamma will then be equal to T1 on gamma, but now P2 over P1 gamma minus 1. And from here, from exactly this expression, we see that there is no doubt that the temperature is directly proportional to pressure, so T proportional to P, for the adiabatic process given here and any adiabatic process. Therefore, since the pressure is decreasing in this process, the temperature will also decrease. So if the delta P is in the ratio, or the delta P is decreasing, it implies that the delta T will also decrease. And therefore, since we already know that the change in internal energy is proportional to the change in temperature, the change in internal energy will be negative. Therefore, we can conclude that the change in internal energy will be lesser than 0 or negative, because this change is negative, and this change is negative because this change is negative. And they're all related to each other through proportions. Therefore, the problem is solved. I hope you find this helpful, and